In this example, again, we have an outside transformation and an inside transformation. However, the difference is we're starting with a previously transformed function and we're making it into another transform function. Okay, so how do we do with this? So the outside one is a little bit easier to work with. So we're going to do that first. So the change in y that we're going to need, well, first of all, we need to get rid of that plus 1. So we're just going to take our original f of x. Actually, I'm just going to write that as y. We're going to take our original y value, and we're going to, first of all, get rid of that plus 1 with the minus 1. And I'm going to make this new equals. This is my old. Okay. Slide it over a little bit here. So I'm going to first of all get rid of that plus 1 here, okay, with the minus 1. The next thing is I need to undo that times 2 and make it into a times 4. So we could do it two ways. We could first of all divide by 2 and times by 4. So I could do it in steps. Divide by 2 and then times by 4. Okay, make sure you times everything by 4. Or we could just more simply put, we could write this as times 2 instead of just doing it in 2 steps. Okay, so we're going to go down 1 to get rid of that plus 1, and then we're going to times 2 to make it into the new function, which is a times by 4. Okay, so that's the x. Sorry, that's the y. The x is a little bit more complicated. So our change in x, well, we need to get to this really is the calculation to our old x. Okay, so this is, we can actually write that as new and old like that. So we have our expression here, and it ended up being the new expression here. Okay, so what we can do is, and this is the way we can think of this is entirely backwards. And what we can do is just undo the whole thing. So we're just going to undo that whole expression by just leaving it as is. This, if I just leave this expression, it will undo all of that. And we'll just end up with just a cos x expression. And then to make it into the transformed one here, well, I need to go plus pi. Well, to get the plus pi, I can just take this minus pi and move it to the other side. So I'm undoing the new expression. Okay, so we can actually do this in one step as negative 2x plus pi, and then we're going to add another plus pi from the other side. And this now represents the change in x. So the new x is going to be, first we're going to flip and expand, and then we're going to shift it 2 pi to the right. And that is my transformation on x. So this is a very easy problem if we can just change our frame of reference. So this really, if we can kind of think of this as, well, we're just this expression as is will undo our transformation. We do horizontal expansion by 2, and then to the right pi. That will get back to the original one. So that is the transformation, undoing that transformation already. And then we can redo this plus pi by moving it to the other side. Okay, so that's a different perspective to take, and it's a little bit hard to kind of wrap your head around, but you may want to kind of think of how that works. But the actual process is very easy. We just make them the inside expressions equal to each other, and then we can solve for the one of the x's. Okay, so number 7 here is given the graph of f of x. So we've been given our original graph here of f of x. So this little piece here represents our f of x. These are going to be our reference points. We just need these 3 reference points. We'll probably be able to figure out the diagram from just those 3 reference points. And what we've done is we've transformed it, and the change in y is just a vertical flip. The change in x is going to be a horizontal expansion by 2. Okay, so first of all, we need to look for the flips. So that is not flipped, that is not flipped. So we can just eliminate those right away. Here we have in B, that is a horizontal compression. We don't want a compression, we want the expansion. So the answer is A. Okay, so let's get rid of those. And our answer that we want is definitely going to be this one here.